Hello, I'm lead meteorologist Thomas Wasula from the National Weather Service at Albany, and I'll be covering part 3 of the Spring 2025 SKYWARN session on thunderstorms, reviewing clouds, lightning, and hail associated with the thunderstorms. First, let's review a thunderstorm day climatology at Albany, New York. Albany, New York typically averages 24 thunderstorm days per year when reviewing the climatology from 1945 to 2023. Albany has most of its thunderstorm days occurring in the late spring through the summer, with a peak in July, and then it tapers off as you move through September and into October. Thunderstorm days can occur at any time of year, even in the cool season months of the late fall through the winter. However, a thunderstorm day is most common in the warm season. A thunderstorm day is any occurrence of thunderstorm on a calendar day. You could have 3 or 4 thunderstorms on a day, but still that only counts as one thunderstorm day. How do thunderstorms form? There are 3 main ingredients for thunderstorm formation. You need moisture, instability, and a trigger or lifting mechanism. And let us review these 3 ingredients. First, the moisture for the Northeast or for Eastern New York and Western New England typically comes out of the Gulf or from the Western Atlantic. Moisture comes in different amounts and quantities, which will help determine the degree of severity potentially with a thunderstorm. Then you need instability. Instability is generated by the heating of the atmosphere. The more instability combined with the moisture, the greater the chance of severe weather depending on the lifting mechanism. In this particular example, and the most common lifting example for the Northeast, is a cold front. A cold front to the west-northwest typically has colder, drier air, and to the east-southeast of it has more moist and unstable air. Other lifting mechanisms could be warm fronts. It could be also upslope flow, a low-pressure system, differential heating. But in this example, we're going to focus on the cold front. And when you bring the cold front into an atmosphere of plentiful low-level moisture, as well as instability to a certain degree, you can have strong to severe thunderstorms. Let's review the cloud formations with thunderstorms. There are 3 phases to a thunderstorm. First, the towering cumulus phase. The cumulus clouds are dominant and grow vertically with updrafts that can extend up to 20,000 feet into the atmosphere. The air is dominated by these updrafts, and this is the initial towering cumulus phase. The second phase is the mature cumulus or the cumulonimbus phase. This is when most of the severe weather occurs. It is dominated by updrafts and downdrafts side by side. The updrafts could extend up to 30 to 50,000 feet in a thunderstorm, sometimes even higher. When you receive the downdrafts, or these updrafts and downdrafts are side by side, you can have tornadoes, large hail, damaging winds, and flash flooding. The third and final phase of a thunderstorm is the dissipating stage. The downdraft cuts off the updraft, so it is a downdraft dominant phase. The storm no longer has a supply of warm, moist air to maintain itself, and therefore it falls apart or dissipates. Light rain and weak outflow winds may remain for a while during this stage, before leaving behind just a remnant anvil top. This is when things tend to stabilize or settle down with a strong to potentially severe thunderstorm. Let's review a supercell thunderstorm and identify its clouds and features. The supercell thunderstorms are a special kind of single-cell thunderstorm that can persist for many hours. Most severe weather occurs from supercells. They're responsible for nearly all the significant tornadoes produced in the United States, and for most of the hailstones larger than golf ball size. Supercells are also known to produce extreme winds and flash flooding. The most ideal conditions for supercells occur when the winds are veering or turning clockwise with height. For example, if a veering wind situation, the winds may be out of the south or southeast at the surface, and then be from the west at 15,000 feet higher and up in the atmosphere. This change in wind speed and direction produces storm scale rotation, meaning the entire cloud rotates, which may give a striated or corkscrew appearance to the storm's updraft. When looking at the picture here, you can see the cumulonimbus clouds, or that second phase of a mature thunderstorm, the overshooting top. Here is your anvil. This is your flanking line to the west here. You also have your wall cloud near the rain-free base, which could produce a funnel and a potential tornado. And then you have your rain shaft, where rain and/or hail or winds may occur. First, let's review a couple of types of clouds. in particular for severe weather. On the left side of this image is a scud cloud. These are generally non-rotating detached clouds found beneath nimbostratus, cumulonimbus, altostratus, or cumulus clouds, and are typically harmless. Continue to monitor as it could be something more dangerous down the road, but in particular scud does not pose any threat to life or property. On the right side are mammatus clouds. These clouds have a cellular pattern of pouches, typically associated with anvil clouds and severe thunderstorms. They are indicative of a strong thunderstorm and also indicative of convective-induced turbulence for aviation. Not always does severe weather occur with mammatus clouds, but be on the lookout for potential severe weather if you see them. Now let's review shelf clouds versus wall clouds. A shelf cloud on the left side of the image is a low horizontal arcing cloud that develops along the leading edge of a gust front within an approaching squall line. This is an indicator that strong to potentially damaging straight line wind gusts are possible, followed by rain. Again, these clouds tend to look like a shelf, and they move from west to east or northwest to southeast, and are usually associated with outflow dominance. The wall cloud on the right is typically a lowering of clouds underneath the base of a cumulonimbus cloud, which can be sometimes a precursor to a tornado. The wall cloud in this image is from Cheyenne, Wyoming. Notice the rain-free base, and typically it's associated by inflow into this cloud, and be on the lookout for a funnel and a potential tornado. But not every wall cloud produces a tornado. Now let's review some lightning safety. First, let's review the do's and the don'ts on the left side of this image. First, do. Go inside when you hear thunder. Do not mess around with thunder and lightning. It can be very dangerous. You can find a sturdy house, a building, or a car with a roof to go in. Stay indoors for at least 30 minutes after you hear the last thunder. This is the 30-30 rule. When you hear the first thunder, go inside for at least 30 minutes because it could be within a striking distance of you. Don't retreat to dugouts, sheds, pavilions, picnic shelters, or other small structures. Do not use or touch electronics, outlets, corded phones, or windows when there's lightning and thunder. Go under or near do not go under near or small trees, swim or be near water, or stand near metal objects. Again, please get inside or in a sturdy vehicle. On the right side here, we review the 30-30 rule. If it takes less than 30 seconds to hear thunder after seeing the flash, lightning is near enough to pose a threat. After the storm ends, wait 30 minutes before resuming outdoor activities. From flash to thunder, every 5 seconds, it's 1 mile away. So if you get a flash and then boom in like a second, it's within 0.2 of a mile. So you must be careful with lightning and thunder. When thunder roars, go indoors. Lightning fatalities. Unfortunately, we have not gotten this number down to zero. Lightning strikes the United States about 25 million times a year. Almost most lightning occurs in the summer. People can be struck at any time of year. Lightning kills about 20 people in the United States each year on average, and hundreds more are injured. Some survivors suffer long-term neurological damage. As you can see, the number peaked around 40 in 2016. We have seen it drop off into the teens as past 2016, but still, we would like this number to be zero. And then when you break down the demographics, it tends to be more men than women. Not sure why, maybe they're more stubborn. But again, we like to see this number zero and make a dash inside when you hear thunder roar, go indoors. Here's a couple videos of what can happen with lightning and how bad it can be.
Damn! Holy! Damn! Holy!
So as you can see from that video, see it flash dash inside, but it looked like half the tree came down from that video. Here's another video.
Did you get that big anvil strike last night?
I wasn't even out.
So you can see the step leader and then the channel down from the lightning and how close and dangerous that was. So see a flash, dash inside. Let's review hail development formation. On the left image here, you can see the updraft for a thunderstorm. Moving up the thunderstorm, when you have the cumulonimbus phase, water droplets are sucked into the updraft, hail begins to form. You see the overshooting top and the anvil to the right, but this mid-level rotation, hail gets too heavy, the updraft, and it begins to tumble down. There could be some melting that goes down. With the cool downdraft, you get the hail out of the thunderstorm. Hail, depending on the strength of the updraft, how much melting occurred, will determine the size of the hailstone. Also, instability plays a role too. And let's watch this short video on hail review. That was a great review of hail formation. We don't get hail the size of grapefruit around here, but we occasionally do get golf ball, and sometimes we've had a few major events where we've had some baseball size hail. So let's review hail safety on the next slide. Also, before we do the hail safety, I should say, let's look at the hail descriptions. Severe hail is 1 inch in diameter, quarter size. It's funny, hail starts like with coins and then gravitates to sporting equipment. We used to use penny-sized hail for severe hail, but after the studies, it was raised to 1 inch in diameter. We do like people to report P, half-inch, or M&M size, penny or dime, because it could be the lead-up for quarter-size hail. And then if quarters are 1.5 inch is a ping-pong ball size. I should say 1 1/4 is $half. A golf ball, 1 3/4, and this is where we transition to sporting equipment and fruit. 2 inches headache. Not every headache is the same size, but that's what's used for 2-inch hail. Tennis ball is 2.5. Sometimes lime is used. 2 3/4 is baseball. A teacup 3 inches. Softball 4, and 4.5 is grapefruit. You measure along the long axis. We ask people to not run out there during the hailstorm. It'll be there when it ends. If you want to take a picture or put a coin next to it or put a little ruler or a tape measure along the long axis, and we'll help you determine the size of that hail. But 1 inch hail is a severe thunderstorm criteria, and damaging winds 58 miles per hour or greater, and again, we do get golf ball from time to time. Sometimes we get larger than that. Significant hail is 2 inches or greater, but it's more common in the plains, the Midwest, the deep Southeast. And here's that hail safety. Basically, if you hit hail, stop or slow down. Stay out of culverts or low-lying areas. If you see a safe place close by to drive, inside a garage or under a service station, then get there quickly. Make sure you pull off the road when you stop to. Don't leave your car on a shoulder. It can be dangerous. Do not leave your vehicle until it stops hailing. Your car will provide reasonable protection. Convertible will not, though, so make sure you have a hard top. Also, keep your windows closed. Cover your face and eyes. Get on the back seat of your car if it's golf ball or larger hail. Baseball for sure will break the windshield. Golf ball will start cracking it. Lie in the back seat. That's an extreme situation. We had supercells on May 15, 2018, and we had several reports of 2-inch or larger hail, I think even up to baseball size. These are from Saugerties on the left. You can see the 2 inches in diameter. We have a video here from Elizaville in Columbia County. Damage to the windshield with this car, but this is the last significant hail event we had in terms of the number of hailstones, and that was May 15, 2018. Okay, that includes this section on hail, and we'll proceed into the next section.